Okay, so this is the question, number of distinct islands on the GFG. So what is the given in the question? First of all, we have to given the grid that is of 2D matrix here and of size n cross m there, and we have to simply find the number of the distinct islands where like what's the definition of islands. Island is nothing but the connected ones there. Let's say if I'm because this is not maintaining at the like synchronous manner there, but like assume it as 4 cross 4 matrix. So see this is a group of when there are the connected, so this seems as a one island there, and like this seems again one island there. So like what is seen there, so two islands are considered to be distinct if and only if one island is not equal to another. So like how to treat it is that identical or not identical. So it means if we are not rotated or reflected over there. Okay, so let's say if you have to see the one of the very like good example for this case. See if I have the 4 cross 5 grid there, means n cross m grid there, and like I have to find the how many of the number of the total of the islands there, or we can say total number of distinct islands there. Okay, so let's say this is the island, this is the grid given here, and these one are these or collectively make a one island there. Okay, now let's say if I'm taking if I'm talking about this island there. Okay, so this is one island there, and let's say this also make a one island there, and like this also make one island there, and this also makes one last of island there. Now if I have to ask you like how many of the distinct islands there, so you see one thing, like there's a 1 2 3 and 4. So we can say one thing there, like we have to simply memorize the numbering of these islands there. We can say one thing that this island and this island is nothing but the similar, or we can say identical, because this is just like assume it like it is just shifted, or we can say this is just placed from this position to this position. Okay, it is neither rotated or neither we can say the like what's the given in the question. Okay, so neither rotated or nor reflected. When you have to see about this island and this island, so we can see like this island is just rotated by 90 degree, so it becomes this. But since it is rotated, means it doesn't behave as identical, so it becomes the distinct island. Okay, so now if I'm asking you like how many of the count of the island there, so it is nothing but the 3 island, because this and this represent one island. This individually contribute to one island, and this individually as a one island. So there's a total of the total we can say the total distinct island is 4, and since it asking for the distinct, so that's why I have to return the count is equal to 3. So this is of the question. Okay, so like so what's given in the question, we simply need to count of the islands based on the what are the shape, not on the position. Okay, means we can say we have to just small the size of this. Okay, so we have to just doing based on the shape, not we can say on the position. Okay, so now like if I will now like how to find this because for the each of the shape we know we have to also know for the coordinates of these. So how I will the normalize each island. So I can say I have to simply storing their cells relative to what are their starting points. So if you have founding the confusing, so let's say first of all I have to write the what are the coordinates for this, so it might be easy for you. So let's say if I'm to just wait a second here. Okay, so like there's a coordinates are is represented in the manner such that if I have to write the coordinates for this identical this island there, so this is nothing but the I can say not using the bracket there. Okay, this is nothing but the 0,0 for this. There's another is 0,1 there, and there's it is of the 1,0. Okay, so these are the 3 coordinates for this island. Okay, similarly if I'm talking about this all islands here, let's say let's draw the lines so that only the remaining part is to write the coordinates there. Okay, let's say if I'm writing about this, so how 0 1 2 3. Okay, so this is nothing but the 3,0 there, and like this is nothing but the 4,0 there. Okay, and like if I'm it is okay, sorry, this is nothing but the there's the row number is 0 there. and there's a 0 comma 4 there. Okay, and if I'm coming to this island there, so 0 1 2 3, so 3 comma 0 for this, and there's we can say, what we can say here, it is nothing but the like how to undo this part here. Just wait a second here. How to just erase this part here. Okay, now let's erase this, write this again. Okay, so this is nothing but the 3 comma 0, and this is nothing but the 3 comma 1 there. Okay, 0 1 2 3 and 3 comma 0 0 comma 1. Now coming to this 0 1 2, so it 0 1 2 3, so it is nothing but the 0 1 2 3, so 3 comma, let's wait a second, can I use it? Okay, so if I'm using this, what is the coordinate for this? 0 1 2 3 0 1 2 3 4, it is nothing but the 3 comma 4 there. And what is its coordinate? So it is the 0 1 2 3, so 3 comma 3. And what are of its upper coordinates there? So it is nothing but the 0 1 2 2 comma 4 there. Okay, so if I'm just wait a second here, so 0 comma 3 there, and this is 0 comma 4 there. Okay, since I'm writing this in such a manner, so I can write this as like just wait a second, I think I might be some mistake here. 0 1 2 3 there, it is nothing but the okay, so like, okay, so it is understable there. Okay, so now if you have to see one thing here, okay, so what we can do here, like I have to simply write the coordinates for each of the island there. Now we have to see whether let's say if I'm take the one of the case there, let's say if I'm taking some island of such let's say if theirs are of the same shape here, they are just nothing but the neither they are rotated or neither they are reflected. So how we can say like these are the same island or not? Like I think there's not example given, because if I think you are facing the difficulty for, because it is not writing in the sync manner there. Okay, so now let's say if let's assume there's nothing but the 0 comma 0, let's say if I'm writing here, so what is the coordinate for this? So it is nothing but the 0 comma 0, it is nothing but the 0 comma 1 there. And if I'm come to the like its down part there, so it is nothing but the 1 comma 0 there. Okay, so let's say these are the coordinates for its and let's say there is again another we can say another island. Let's assume if this might be another island there, so this is kind of the shape there. So what are its coordinate there? It is nothing but the 0 1 2, so it is 0 1 2 3. Okay, so it is nothing but the 2 comma 3 there. After it is 2 comma 4 there, and after it we can say the 3 comma 3 comma 3. Okay, now see, like we can simply see by the eyes like these are similar, but how to prove it mathematically that these are similar? Not. Okay, now how to do this part? So I can do the normalization for each element by storing its cells related to starting point. Let's say these are my starting points. If I have to subtract from this like this is my starting point here and this is my starting point here. Okay, if I'm trying to say what I'm trying to say, I just convert these coordinates. So how these coordinates become as, like this is nothing but the 2 comma 3. Okay, let's say I have to write this 2 comma 3 there, and what are its another coordinates? This is nothing but the 2 comma 4 there, and what are its another coordinate? This is nothing but the 3 comma 3 there. Okay, if I have to subtract, what I can say, 2 comma 3 there, so what it becomes? This is nothing but the 0 comma 0. Similarly, if I have to subtract the 2 comma 3 there, so this is nothing but the, we can say 0 comma 1. Okay, similarly wait a second. Okay, similarly we can say if I have to subtract the 2 comma 3 there, this is nothing but the 1 comma 0 there. Okay, so I think now you can see this is nothing but the same like in the same manner or same order, like when you have to subtract from this starting point, and since it is also same, so that's why it gives the point resemblance to this. Again 2 comma 4 it becomes 0 comma 1, 3 comma 3 becomes 1 comma 0. So by this we can say by mathematically that these are the similar. Okay, so this is the method like how to prove this the islands are same, or we can say that like this is very general formula for how to proving any shape are the similar or not. Okay, so now what we can say, so same shapes means they have to there are the same representation there. Okay, so now come to the question, and like now I think now it is much easy for you. So like how you can simply, what you can simply do here, first of all we have to traverse all of the grid there. Now when you find what are the unvisited land cell, let's say if I have to traverse this and if I have to found this, there is a 1 and it is not visited, means this is our target. So what we can do, we have to simply start our DFS from here, and we have to simply store what are the island shape as simply by as relative coordinates there. And like what's mean of relative, this is nothing but the current coordinates minus what are their starting coordinates, or we can say there is a base coordinate. Okay, so that gives me that difference gives me the relative coordinates. So I have to simply use this part. Okay, and like simply insert this in our set so as to, so that to it doesn't, and we can say like let's say if I have to create one set here. Let's say there's a set is given to here. Okay, now I have to include all of the relative coordinates of all islands in our set. Okay, so let's say if I have to simply insert these value in our this, so there's a 3 point there. Let's say there's a 3 coordinates there. This is nothing but the x comma y, x comma y, x comma y, because there are the 3 elements. If I have to insert this is nothing but the there's a like 2 points there. There's one xy there and there's one xy there. Okay, now if I have to insert this and this relative position, this relative this relative coordinates and this relative coordinates are given the same values, because we can see this is nothing but the 3 comma 0, 3 comma 1. If I have to subtract 3 comma 0 from both, so it is nothing but the 0 comma 0 and 0 comma 1. Similarly, if I have to subtract 0 comma 3 from both, it is to become 0 comma 0 and 0 comma 1, means they are same. So if I have to insert these in our set, so these doesn't produce duplicate values, because this is set, so it has to avoid that duplicate values, means we have to insert this, so it can already insert this. Okay, now come to this value, so it has already different we can say configuration, so it has to store there. Okay, so finally by the size of this set we can simply represent what are the distinct islands in this question there. Okay, so simply return we have to return the size of the set there, like we can say here the what are the size of set. Okay, so this is nothing but our answer there. Okay, so now come to the coding part. Now I think like you can understand this part, or if you like during the writing of our code you can understand it a bit more. So like simply first of all initialize our answer there. Like first of all we have to initialize our the we can say, if I'm to using the v here, because it is much easy for me. Okay, so this is nothing but the for the row position there, and if I have to write the for the I don't know why is mistakes there much more there. Okay, so it gives me the and there and this I'm there. Okay, so like since I have to judge whether it is unvisited or visited, so for the tracking part there I have to use one visited vector there. This is nothing but the vis of, we can say, n comma . and since all are still initially all are unvisited, so that's why I have to use or 0 there. Now what is given here? Okay, so I think it is okay. And since also we have to store our we have to use a set, and how to initialize our set there, since there are the number of the coordinates in island. Let's say there's a 3 coordinates, there's a 2 coordinates, so we can say we have to simply store what are the vector, and in the vector we have to simply all of the pairs, that this is x1 comma y1, x2 comma y2, x3 comma y3. Okay, so we can say how to initialize our vector. So this is nothing but the I don't know why it is giving those such so much. Okay, so this is for the set vector. Now simply we have to simply traverse this, and how to do this. So now we have to see if the current position at we are standing, if it is non-visited, and if it is its value is equal to 1, because that's only it means we are standing at the island. Okay, so in that case what we can do, we can simply first of all we have to simply shape any of the, because let's say if I'm to discuss only about that island, so for which I have to make one vector there and simply store what are the all of the coordinates of this config or cells contained in this shape. Okay, so to store this we have to simply make out the temporary let's I think just rename this as a shape there. Okay, so this is our vector there, because this is for storing for the current configuration of our shape there. And now call for this part, there's nothing but the I comma j there. Let's okay, and there's a v vector there, there's visited vector also passing here, there's I comma j, and don't confuse it, it is nothing but the, see this I comma j, these are the current coordinates, and these are j is nothing but the base coordinates, because by we can say by subtracting this part, this gives me the relative configuration, so that it is might be understandable. Because I can say we have to simply given what are the row comma column there. Okay, if I have to subtract the r naught comma we can say column naught, so that gives me the relative configuration, so that's why. Okay, so since I have to make running our dry run there, so after it what we can do, simply after it we can say we simply has to insert what is the shape, because by this DFS let's say if I have to call DFS for this part, it has to goes to this, okay, and if it has to cover all of this, because its neighbor containing 0, so it doesn't exceed to this out of the shape there. So by this it has to cover all of these configurations of the shape. Simply store this in our vector that is named as a shape, and after containing the shape there, we have to simply insert this shape vector into our set there. Okay, and finally we can say we have to simply return what are the size of our set there. Okay, so that is the code. Now the definition of how to how the DFS code work here. So let's write the DFS code here. So how to do this, this is nothing but the DFS passing is as, firstly we have to pass our intro, this is nothing but the int column there, and after it we can say first of all we have to pass our visited vector there. Okay, let's write it again there. So this is our visited vector there. After it what we have to pass, we have to simply pass our set. So let's don't write it again, so it is simply copied by this, and we can say we can write this as just wait a second here. Okay, so this is the our set is vector. Just wait a second here. Okay, so after it I have to I think pass all of the no, there's something remaining. Okay, so I have to pass this. Now after it we can say we have to simply pass what are the R node there, and similarly I have to pass what are the column node there. I can also rename this as the row base and the column base, but I don't make it as so much of the complicated for you. So let's rename it as a simple variable naming there. It is going there. Okay, so this is the parameters passing in the DFS. Now just we can also pass our no comma m in this value there, or either we can just similarly simply copy paste this part there. Okay, so this is nothing but our n comma m there. Well, the first step what we can do here, this is nothing but the simply make it as visited there. After it we can simply store the relative. We can say store relative position. So how to do this part? This need to shape there. From it we can say there's nothing but the r minus r node there and c minus c node there. Okay, so this is the meaning of this r minus r node there and c minus c node there. Simply push this in our shape there. After it, since in our previous cases in our simply graph questions, since it is given as the graph, let's say if I'm standing at this position, now it has a 4 direction, either is up, down, left or right. So I already explained in my previous video how to do this part. We simply has to use our dr vector there and dc vector and simply store what are the relative positions for this. Let's say if I'm standing at r comma c, so there are the 4 coordinates, 4 positions for this. Either it is goes in the, let's say if I'm calling it as r comma column plus 1, r plus 1 comma column, r comma column minus 1, or r minus 1 comma column. So what how to handle this part here? So it is nothing but the we have to simply use our dr vector. So this is nothing but the so this is minus 1 comma, we can say 0 comma 0 1 comma 0 Okay, so this is the into dr dc. Now what we can do, simply traverse in all of the 4 direction. So how to do this part? So that is our the first of all nr is nothing but the new row. So how it is attained there? This is nothing but the dr of I. Okay, similarly we can say this a new column is nothing but the column plus dc of I. So that gives me this value. Now first of all we have to validate, check whether there exists or not. So nc is greater than 0 if nr is less than n and nc is less than m. Okay, and now we can say if our visited there. Now what we can say here, if these are not, since this should not be the not visited here, and there's a nc there, and v of nr and nc is equal to 1. Okay, so what it means, these are simply for the checking whether there exists or not, and this is, it should not be the visited till that point, and it should represent 1, because only in that condition it means it has to simply the length part here. Okay, after it what we can do, we have to simply call dfs for it. So the current coordinates are become nr and nc there, and what are the another things we can pass in this? There's a v, and what are the things remaining there? Okay, so what are the things remaining here? I think I'm confusing here. There's a shape we have to pass. This is okay. Like I'm writing one one mistake here. See, there's not need to pass the set, because at the final end, because what are the purpose of DFS? We simply have to make our shape vector, and after making the whole of the shape vector, simply insert this in our. So there's no need to. So like what are the things we have to pass to here? So this is nothing but our shape vector here. So I have to simply so like this is our shape vector here. So simply copy this part here, and like after this is nothing but the end there. Okay, so I have to pass this shape, and like so how is the ordering of the pass of the parameters in our DFS for the neighboring? So there's a NR, NC, V, and the shape here, and now after it we can say there's our N. This is nothing but the R node, and this is C node. Now don't confuse it, like you have to see if you have to pass the there's a this should be the changeable, so it is not changeable. Why? Because whenever I am talking about any particular, let's say if I am standing at this island and I have to calculate what are the vector made for this, so I have to simply difference what are the difference. We have to simply difference 2, 3 from all of these. So this 2, 3 is fixed there. So that's why this is nothing but this is the starting point of our island. So let's say if I have to dealing for this. So what are the starting point? Let's say this is our starting point. This is so it nothing matter there. Okay, so I comma j is starting point of that island. So that's why this is remaining the same. So that's why r comma r naught and c naught is remaining the same here. And like if you have to write the DFS for this, okay, so there's the thing done there. So after it we can say, so the DFS is starting there, and there's the code for this, and so this is the question there. And like now talking about the what are the time complexity for this part. So first of all, if I'm to during traversing of I0 to n, there's a 0 to m is j is going to there. So this is the n and there's the m. Okay, so n cross m, the time complexity for this. And like for each part we have to simply calling for the DFS, and for the set insert it has to insert the shape. Shape means in the worst condition it has to insert all of the values. And what are the like for each time DFS calling, so it has the 4 direction. At each time it has to call for it. So in the worst condition it has to call for n comma m, n into m. So it means it has to simply insert the, we can say n into m into 4. Let's use wait a second, why it is done here. Okay, so it is nothing but the n into m into 4 there. Okay, so it for the each time, and it is calling for the n into m. So we can say like if I'm calling the time complexity, so it is nothing but the n into m plus n into m into 4. Okay, like it is calling for the each case, but and after using it we have to also using the inserting. So it takes the log time there, and let's log time. What are the shapes? So let's say it takes a k value. In the worst condition it takes n into m, but it doesn't matter. Okay, so it is nothing. What is the comparable time complexity? It is nothing n into m into log k. Log k is nothing but the we can say the time complexity for the inserting, like what are the size, what are the size of our shape vector there, and what are, if I'm talking about the space complexity, so it is nothing but the space complexity is nothing but the O of n into m there. Why it is? Because actually it is n into m for this and for the set also, but comparatively we can say the n into m there. So this is our question there.